So now in this video, we have an active buzzer right there. All you have to do is apply power and it buzzes. It's really annoying though. So I'm going to try to keep it to a minimum. I believe I picked this resistor value. If I also bump it, you kind of hear clicks, little buzzes I mean, when I lose connection, because then we can get current flow. So in any case, 220 ohm resistor, that helps adjust the sensitivity. We could swap these two. You'd probably have to use a different value for the fixed resistor though. And if the light dependent resistor was on this side, then brighter light would turn the buzz off. When it gets dark enough, that's when it would buzz. You may have to adjust the values there though. This is the main resistor. You would usually have to adjust in most cases if you want to change this circuit, other than swapping these two spots so that it reacts to dark instead of buzzing at light. So in any case, I have the light dependent resistor covered right now. If I remove it and turn the lamp, I believe this is what I originally set this up for, was for it to buzz when I turn the lamp on and turn off when the lamp is off. So now we have the active buzzer. Usually I leave this paper covering it, but it says remove paper after washing. And then it is polarized. We got the plus up there for the top pin, and there's epoxy in there. So that is how all my active buzzers are, with epoxy. The ones where you can see circuitry in there are passive buzzers. You actually have to give them a changing voltage, steady changing voltage to get a buzz. And I don't know what I did wrong there. Okay, so I got everything connected better. So in any case, that bottom pin's coming to the collector of the NPN Bipolar Junction Transistor. It's pointing to the right. We got the buzzer to the collector, and then base, that 220 signal, and then the emitter down to ground right there. Transistor is facing to the right. You can see the resistor there coming to the base, the middle pin. And so when the transistor is off, then there's no connection to ground. We need current to flow, kind of a significant amount of current. Not a ton though, but transistor needs to be on for it to buzz. Otherwise, no current can flow and it will not buzz. I don't know how much higher you can go than 5 volts with these. I think they may even work down to 3 volts. So I can't tell you on that. Look at what the seller says you can use when you are buying them. And so it's really annoying buzz. I'm going to cover my finger. We'll look at the current. And there we go. Looks like we need about 33 milliamps of current or so. Usually I set this to 20 milliamps to protect LEDs in case I short something. If you do not have enough current set, it will lower the voltage. Oops, it's on. I need to remove that right there. So you can see we got 20 milliamps of current, and that's what we limited it to. And I can change this setting. We can look at the voltage that is being provided. It's still on. I got to remember that. And you can see it actually has to cut down the voltage to get the buzz down, to keep the current limited. Because if it had a higher voltage, more current would flow. So that's how this works. If you set a voltage and it doesn't need more current than what you set, the voltage holds steady. But if you want more current than what it's providing because of the voltage, then it lowers the voltage to keep the current limited. Hopefully that makes sense. I think that's a good time to explain that, because this is usually what I have, 20 milliamps. But for this circuit, I really should have 40 milliamps. And so yeah, that is it. I won't worry about that power supply anymore. That's about it. I'll zoom in here again to end this. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.